Mrs. Traver here. Today we're going to talk about slope as a rate of change. Your learning target for today is to be able to understand speed as a rate, and you'll be able to describe slope in a real life situation. Let's jump in. So here's my first example. We've got a little story problem for us. We've got Leslie, Kristin, and Evie who entered a race. Leslie began at the starting line and rode a constant rate of 2 meters every second. And I want to know the equation of Leslie's travel. Now it says riding, so I'm going to say maybe they're riding horses or something. So let's see if we can figure out the equation of Leslie's travel. So we've talked a lot about different equations with the context of like tiles and patterns, and that's kind of the mindset here. If I can get my pen to work, that would be super cool. There it goes. All right, let me start fresh on this slide. All right, let's see. We've got Leslie, Kristin, and Evie who entered a race. And it says Leslie began at the starting line and rode a constant rate of 2 meters every second. Now, that's pretty fast. I'm going to guess she's on a horse or something. I want to know what's the equation of Leslie's travel. So I want to highlight something for you that's important. It said a rate of 2 meters every second. So notice how it says of, and then it says every second. That is a rate. That is what they're talking about when they say rate. So rate, we know, is slope. And slope is usually like rise over run. And we used to talk about it as number of tiles by a figure number, if you remember those. But now we're trying to switch it up and put it in the context of this problem. So now it means meters per second. So number of meters for every second. So in this case for Leslie, her slope was 2 meters for every 1 second. I could reduce this to just say 2. So the equation of Leslie's travel, we can say y equals 2x. That's supposed to be a 2. Y equals 2x, and then usually we put a b here for the y-intercept. That's where you start at. The starting line is where she started. So she started where it said 0. So 2x plus 0, or I could write just y equals 2x for Leslie. So there's Leslie's line. All right, Kristin now, she had an 8-meter head start, and she rode 2 meters every 5 seconds. So let's see. Here is her rate, 2 meters every 5 seconds. That is the slope, or the rate, however you want to think of it, 2 meters for every 5 seconds. And then she got an 8-meter head start. That is my starting point. That is my y-intercept, where you start. So let's see, we've got 2 over 5, x plus 8. That's for Kristin. Evie is last. She got a 6-meter head start, and she rode 5 meters every 4 seconds. So we can see our 5 over 4 is our rate, and our 6-meter head start is our y-intercept. So I've got 5/4 x plus 6. So we've got 3 people going, and they're going at different speeds, and they're starting at different points. It says if the race is 20 meters long, who won the race? So let me go back and grab all of our equations. Let's see. We have Leslie at y equals 2x. We have Kristin at 2/5 x plus 8. And lastly, we have Evie, who was 5/4 x plus 6. Whoa. 5, I already forgot. 5/4 x plus 6. Let me fix this little craziness here. All right, let's see what we can do here. Let's plot each of these lines, and we're pretty good at plotting lines at this point in our life. So let's see, with this first one for Leslie, she started at the starting line. That would be down here. Notice too, we have our x and y axis, right? I'm going to label those. And I also want to notice some things about it. When we were talking about our slopes, we were talking about meters per second each time our slopes were in that situation. So because it's meters per second, my x values are really talking about meters, and my y values are talking about seconds. So now that I know that context, that'll help me out a little bit. So anyways, Leslie started at 0, and she went rise to run 1, rise to run 1. I'm going to plot it out all the way to make this graph nice and pretty so I can see later where all of them work together. See how good I can do connecting the dots. Not too bad. All right, now we've got Kristin. So she started at 8 meters. So she gets to start way up here. 1, 2, 3, 4, 5, 6, 7, 8. And she rises 2 for every 5. Rise 2, run 5. 1, 2, 3, 4, 5. Count them out, take your time, use precision on these type of problems. All right, so there is my Kristin line. Lastly, Evie. So she starts at 6 meters in, and she rises 5 for every 4 seconds. 1, 2, 3, 4. Oops, I'm off the graph, so I'll have to use that. All right, there we go. So I've got each of my people here. Let me label them on here. Here's Evie and Kristin. Oh no, wait, yeah, Kristin and what's her name? Lauren, I think. All right, so it says if the race is 20 meters long, who run the race? So let's see, I drew arrows on the end of each of these, but really the race ends after 20 meters. So let's see where 20 meters is. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 20, here's 20. So I'm gonna put a line here to recognize where 20 is. And my question is, who gets there first? Definitely Kristin. You can see how these lines would extend out, and eventually up top, if like your computer screen or your phone screen or whatever you're looking at could extend out, they would eventually get there. But Kristin gets there the fastest. She got a head start, and that helped her out quite a bit. So who won the race? Kristin won. All right. So here's a different mindset. I've got a picture here, and notice that the X and Y's have changed a little bit. So the X says years since planting, and the Y says height of a tree. So I can see what this is talking about here. We planted a tree, and maybe 1 year in it tells me how high it was, the height of it, 2 years in, and so on. So notice there's that point bolded in 5, 4. That is a situation where it's saying after 5 years, so this point is really telling me after 5 years, the tree was 14 feet tall. The tree was 14 feet tall. So in this case, what does slope represent? Well, it's rise over run, we know. And rise is height in this case. So this is the height in feet. Over the run is X's, years since planting. All right, and then let's see, what's the rate of change? So I'm trying to look for the slope in this case, and I see a point here and a point here. So let's see, from 4 to 14, it rose 10. And from 0 to 5, it went up 5. I can reduce that to 2, so I can say 2 feet per year is its rate of change. Notice how I just did the numerator over the denominator, and I put per in between to show that it was a rate. Moving forward, another one like this. We've got time in months in the bottom, and we've got bank balance on the top. So this is how much money you have in your bank account as time goes on, and notice it's going down. You're spending some money. So in this case, what does the slope represent? Well, the rise is the bank balance in dollars, and the run is the time in months. The rate of change is really talking about our slope, so let's find the slope between these 2 points. Let's see, the rise, it went from 130 to 150, that's a rise of 20. And the run, it went from 4 to 2, or I should say, this point goes here. Yeah, from 4 to 2, wait, hang on. It's a 2, right? But is it positive or negative? That's my point that I want to make mention of here. It's going down, so it's negative is my point. So that was the down. So I've got negative 20 over 2 is really negative 10. And then I can use this to write my rate. It's dollars per month. So I'm going to say negative $10 goes in front per month. So just to mention, when you're putting dollars, it goes like this. It does not go like this. Don't do that. Don't put the dollars in the back. You say it in the back, but don't write it in the back. All right, last one. What does slope represent? We've got gas in gallons per distance in miles. So this would be gallons per mile. And the rate of change in this case is talking slope. So it rose, it went from 2 to 4, it went up 2, and it went from 44 to 88, it went right 44. So 2 over 44 can reduce to 1 over 22. So I could say 1 gallon per every 22 miles. So 1 gallon per 22 miles. All right, guys, that is it for us today. I hope that this setup on slope is looking good for you as you notice it's a speed or a rate of change. I will see you next time as we continue talking linear functions. Bye, guys.